Today's recording is part of the EKS Anywhere series. And if we go to the EKS Anywhere website, you can actually see it's coming soon. Working with the folks at Amazon, I believe they're going to be launching this in the up and coming weeks. However, we've been working with their beta program to do some integration and testing with F5 Big IP using F5 CIS running in this Kubernetes environment on-prem in the EKS Anywhere cluster. And so the EKS Anywhere cluster is a Kubernetes cluster that is provisioned in VMware, or at least on VMware, and in this environment there are multiple nodes that are provisioned. We created a small cluster just for integration and testing purposes, but I'm sure you can scale this cluster out to your needs. This specific video that we're going to talk about today is F5 CIS using something called service type load balancer. Some people call it service type LB. There's different ways to define it, but ultimately what are the benefits of service type load balancer is really simplicity. And simplicity because the user doesn't need to define a resource definition. A resource definition being in a route or an ingress or a CRD or a config map. There's so many different kinds of things. With a service type load balancer, you really just define the object of load balancer inside the service. So from a simplicity perspective, it's super simple. Now, service type load balancer configuration is quite synonymous for public cloud, and the reason for that is the external IP has to be defined, right? And so you have to get that public IP from somewhere. So in a CIS environment, we actually get the public IP and we maintain the IP status through Ipam. And so we actually have a controller that's running that is able to provide public IPs to the services based on a range. And that's ultimately what this is really talking about. So again, service type load balancer, it's natively supported through Kubernetes deployments. It's quite widely used. There's a lot of organizations that use it. But what's unique about CIS is that we work with an Ipam controller that allows us to fulfill this need. And as you can see, all that we need to define in the service itself is two things: type load balancer, and second, the Ipam label. And the Ipam label of equal to test, in this case, test is just an arbitrary name. But that label is important because that's what ties the range. The range, think of it as like a scope. We use scopes in like DHCP, something very similar to this. And so that's what ties it in. It will pull an IP off that range. And we're doing a lot of work on the F5 Ipam controller that runs in Kubernetes. So for example, we integrate with info blocks as well. We're adding persistent storage so that we maintain persistence, whether there's a reboot or a recreate, that type of stuff. So there's a lot coming with regards to the Ipam controller. But Ipam controller is pretty simple. Allocate release of IPs. So let's take a look at this guide. And so as you can see from the diagram, it's very simple. CIS is going to update the service whenever the load balancer IP address is blank or empty. So if it sees that there's a service, if this type load balancer IP is blank, it's going to assign it, and it's going to get it from the Ipam controller, or it's going to get it from this Ipam CR, which is a custom resource. The F5 Ipam assigns the IP address for the load balancer for the ingress objects based on the range. And once the objects are assigned and updated with the IP address, CIS is then able to configure, or if you want to call it plumb, the big IP with that public IP. There is also defaults that have been configured. So we're using AS3. AS3 has something called a service. In this case, it's a service type of HTTP, and there are a bunch of defaults for persistence cookie, etc. Those can always be overwritten, but not when you're using type OB, because in type OB there's no resource definition. So you're assuming defaults. It's the simplest of simplest way to create an ingress. So if you take a look at an example service, and we'll take a look at a service now, if you actually take a look at a service, you'll actually see that there are some services created. In this case, there's a service created, the service right here, and the service has a name of test. So we can actually go to Kubernetes. I can do kubectl get service, and we can actually see the service there of F5 demo. And what I can actually do is I can actually do a kubectl describe service F5 demo, and you can actually see by just describing it, you can see the name, there is the label, there is the test. So it's very similar to kind of what we saw over here. So this service is already defined. Now when the service gets defined, that's what basically puts the virtual IP on the actual big IP itself. So some of the prerequisites, very simple. We're implementing AS3. In this case, I'm using CIS 251, which is the latest release. I'm using the latest release of the Ipam controller. Some of the Ipam controller configurations. Let's go take a look at an example of the Ipam controller in step 2. All that CIS needs is an argument that says Ipam is equal to true, and then CIS will work with the Ipam controller. They are kind of deployed separately, so you can deploy CIS first and then deploy the Ipam controller after, and that's what you can see here. So I said Ipam is equal to true. I deployed CIS. I deployed CIS as CRD, which is important. You can find the examples here in the repo. And then when you configure the Ipam controller, use the following arguments. Orchestration is equal to Kubernetes, because that's my orchestrator in this place. At this time, we might change some of the orchestration at a later time. Here is the range. This is the range or the scope that I talked about. I'm just doing some testing. I have a very simple range. It really doesn't matter for me, but this is a range. I called it test. You can call it anything you want. It's just a scope, range of addresses. I'm using debug only because this is non-production. If you're using production, change all login to info. Please, really important. I'm trying to emphasize that now as best practice. Make sure your login is info. A couple things that you need to do. There's a role-based authentication or some RBAC for Ipam. Load the schema and create the deployment. The schema is because we're using a CRD. We need a schema. So you can actually see when you create this controller, I can actually go and do a kubectl get pods -n, and it's in the kube system namespace. You can actually see there are the two F5 CIS and F5 controller, right? Those are the two pods that are deployed. And you can actually see it here. This is actually a very simple log. It's created the new client. It's reading the scope. So there's the labels, there's the scope. It started the listener, it started to listen, etc., etc. So now what it's doing is it is basically starting the worker. So now it's waiting for requests. It's basically waiting for services to be defined, and so that the communication can be created. So at this point, let's go and create a service. And so there's a couple of very simple services in this example, and so I can go take a look at some services, and then we can go ahead and create these services as well at this point. Okay, so let's go take a look at the big IP. You can see on the big IP right here in the tenant EKS, there is no configuration, right? So at this point, it's completely blank. So what we need to do is we basically need to create the deployment and we need to create the service. So let's go ahead and take a look at the deployment. So it's a very simple deployment. It's pulling in an HTTP service running on port 80. So pulling in a simple container, simple Docker image, going to create a container on port 80. Right, simple. F5 demo is the name. Looking at the service, this is a little bit more complex. So the annotation here is to use the Ipam label. There's another annotation also to set a pool member, a health monitor on port 80 as well. That's another annotation. Just look in the docs, you'll find that example. I didn't put it in this example, but that annotation is also supported. And you can see right here, type load balancer and the status as well. So this is ultimately what you're creating here. And then this will will pull the address from the Ipam controller once this is created. So let's go ahead and create this, taking a look at my directory structure. So kubectl create -f, and so what I just did is I just created the pod and the service. And so you can find these files inside this repo. You can actually just clone this repo, pull these files if you wanted to test this. And so at this point, what I did is I just created the service, and so I can actually at this point take a look at the logs. If I want to take a look at the logs of the Ipam controller, let's take a look. And so, you can see there that the actual record was created. I actually deleted the record. I paused the video and deleted the record because Big IP was configured. I actually wanted to show what Big IP looks like. But you can actually see here that there's a new request coming in. It's allocated an IP address from the range, from the pool, and it created the record. It updated this A record in the Ipam controller itself. So that's actually kind of cool. And then if we take a look at Big IP, we should see the virtual configured, which we do now. We actually see this virtual configured. If I go into the annotation and enable the health monitor, we will see this go to green, or at least this pool member will be green here. You'll notice that my pool members are 26 and 27. I'm using node port. That's just the implementation that I'm using at this point for this demo. So node port is the nodes in the cluster that are part of the pool members. So all traffic will go from Big IP to node, and then from the node directly to the pods. So another thing that we could do is if we wanted to, we could actually look at this Ipam controller configuration. And so let me just stop the logs. And so if we look at the Ipam, we can actually see here that there is the external IP and there is the Ipam controller manager. So it's just some interesting information. It's kind of cool if you're using Infoblox, because I'll actually show you more. With Infoblox it's a little different because there is the DNS piece. So because we're not using a range necessarily, we're going to use host names. So the host names will be matched to the IP address based on Infoblox, based on the DNS name, or based on the host name. So that's actually kind of cool. A couple other things that we can do here is that we can do a quick kubectl service. So we could actually get the external IP, which I think is nice. So you can see there is the external IP. So hypothetically, if I plug that external IP into my browser, it should actually work based on this configuration. And of course it does. You can see there that is the host, that is the external IP right there, that is configured. See, there's the external IP, there's the external IP, and if you go look at Big IP, you'll see that there is the external IP. So let's recap. So if we look at the architecture, it's all running in EKS Anywhere. So EKS Anywhere is a new offering from Amazon. It's going to be available shortly. And so I deployed my EKS Anywhere cluster on-prem on a VMware environment, and within that cluster, I created the F5 CIS controller. I created the F5 Ipam controller. I went ahead and created the deployment and the service. And since I'm using type LoadBalancer, which I specified in the service, once that is created, CIS will work with the Ipam controller to define an IP from the range and associate it to that service as a public IP. And as you saw, I was able to connect to that service. So thank you very much. If you like this demo, subscribe, like, comment. If you want to see different demos, please go ahead and let me know, and so that I can create the documentation and record the demo. Inside the link below, you will find the user guide, which helps you with the configuration, etc. You can clone this repo to pull the files in. Thank you very much.